You know, we often blame weak AI models when our workflows inevitably fail. We get frustrated. We say the model just isn't smart enough. Beat. But the real culprit is usually just poor memory structure. An AI without memory is kind of like a brilliant coworker who gets amnesia every morning.
Right. Exactly. You spend an hour explaining the nuances of a project. They
Yeah.
understand completely. They do incredible work. But then the next day, you have to explain it all over again.
It's completely exhausting. Welcome to this deep dive. I'm so glad you're here with us today. We're unpacking an incredibly insightful guide. It's all about the architecture of AI agent memory.
Yeah, it's a massive shift in how we interact with these tools. We're finally moving from single, isolated conversations to continuous collaborations. It really changes everything about digital workflows.
Okay, let's unpack this. The overarching problem is something you've definitely experienced. You give an AI the perfect prompts, you upload the exact right files, and it nails the task.
It feels like magic. But then, you close the tab, you start a brand new session.
And its brain is just wiped completely clean.
Yep. Total blank slate.
It repeats those same fixed mistakes you just corrected yesterday. Explaining everything from scratch completely ruins the momentum. It kills long-term projects.
It creates massive friction. You lose that flow state entirely, which, it totally defeats the core purpose of having an automated assistant.
So our mission today is to fix that exact problem. We're going to explore 4 distinct types of AI memory. That covers working, semantic, procedural, and episodic memory.
It's a great framework.
And we'll look at how platforms like Claude Code are using them. They're actively evolving from basic chatbots into true continuing agents.
The transformation is honestly remarkable. We aren't just building chat interfaces anymore. We are building capable digital colleagues now.
So let's start with the most basic layer of the stack, working memory. This is essentially what the AI sees right in front of it.
The immediate reality.
You really can't plan for the future if the AI gets completely overwhelmed by the present moment.
That is a perfect way to conceptualize it. Working memory is simply the active context. It's the immediate information the AI uses, just for whatever specific task you just gave it.
Right. So this layer includes your current prompts. It includes the files you just uploaded. And it also holds the recent chat history of that particular session.
Exactly. And this entire layer relies heavily on a core concept. Developers call it the context window.
Let's define that term really quickly, just for clarity. A context window is the temporary mental workspace holding current chats and active files.
That is a perfect definition. You can think of it exactly like RAM on your computer. It allows the AI to hold and manipulate information in real time.
But just like physical RAM, it has incredibly strict limits.
Oh, absolutely.
Yeah.
Because the system automatically clears itself out the second you start a new conversation.
Right.
It has to. There's a strict physical ceiling on text processing. Computing power simply isn't an infinite resource.
Yeah, that makes sense.
And even before you hit that hard ceiling, there's another issue. The model's underlying attention mechanism gets severely diluted.
Which leads to a massive mistake. I see users making this all the time. Say you're a coder. You just want the AI to fix a tiny checkout error.
Oh man, I know exactly where this is going. It happens constantly.
They get frustrated, right? So they just upload their entire code base.
Yep.
They throw in 3 old debugging chats. Then they add a massive API documentation file for good measure.
It's a complete disaster for the model's performance. What users often don't realize is how the AI physically reads that data.
It has to scan the whole thing, doesn't it?
Right. The AI has to scan that massive text block from start to finish on every single interaction.
And doing that drains your message limits incredibly rapidly. But worse, it completely reduces the accuracy. The actual error log you care about just gets buried.
You're essentially burying a tiny needle in a massive digital haystack. The AI's attention mechanism gets stretched way too thin, and it eventually starts hallucinating.
Or it just ignores key details entirely.
Yeah.
I still wrestle with prompt drift myself. I always try to jam way too many files into one single session just to feel safe.
Well, we all do it instinctively. It just intuitively feels safer to provide maximum context.
But it's like stacking Lego blocks of data onto a tiny, fragile desk. Eventually, the whole desk just collapses under the sheer weight of it all.
What's fascinating here is the counterintuitive fix for that cognitive collapse.
Yeah.
Less is actually more.
Less is more.
Yeah. A hyper-focused context window consistently gives you much better results, far more reliable.
So the best practice is incredibly strict. You give the agent only the specific file it needs. You provide the exact error message, you include the relevant rule, and you explicitly state the desired result.
And you include absolutely nothing else. You have to keep the current task crystal clear and isolated. That is the only way you sustain a reliable workflow.
So let me ask you this. How quickly does the output quality actually degrade when you start overloading that working memory?
Oh, it happens almost immediately. Once you push past the core facts, the AI just loses focus and makes careless errors.
Overloaded active context immediately causes careless AI errors.
Precisely. You have to aggressively protect that active workspace at all costs.
Which brings us to the very next challenge. Since we just established that working memory must be kept extremely small and hyper-focused.
Right, you clearly can't put everything into the active chat window.
Exactly. So where do we actually put the big overarching project rules? We have to move from the fleeting present to something permanent.
And this is exactly where semantic memory steps in. It's the architectural layer that finally solves that amnesia problem.
Semantic memory is essentially stable, permanent knowledge. It's the foundational context the agent can effortlessly reuse across many different sessions.
You never have to waste time re-explaining the basics. Think about things like corporate brand voice guides or, specific product inventory details.
It holds those approved company methods that never really change.
Exactly. The source material uses a really great example from Claude Code to illustrate this. They simply place a file in the root directory. They call it claud.eatmd.
It is an incredibly elegant solution. It's just one simple markdown file living right there in your folder.
And this single file tells the AI everything crucial about the environment. It outlines what coding framework the site uses, like React or Vue.
It specifies exact operational constraints, too. It might dictate which specific testing command must run before any change is accepted.
Here's where it gets really interesting. When people hear the phrase agent memory, they immediately assume it's this massive, hyper-complex database.
Right, and it really doesn't need to be complicated at all.
It's actually just handing the AI a permanent rulebook for the game before it even steps onto the field to start playing.
Mechanically speaking, when an agent begins a new task, it quietly retrieves that rulebook. It naturally absorbs those baseline constraints in the background.
Before formulating its very first response. So the user doesn't need to spend their precious working memory explaining those baseline rules over and over.
The AI just intrinsically knows them.
And this concept isn't just for software coding. It perfectly supports heavy content creation work too. A writing assistant can automatically check a brand voice guide
before drafting a single word of a blog post.
Exactly. It anchors the AI with reliable, stable knowledge.
2-sec silence. But let me push on this a bit. In a fast-moving environment, how often does the semantic memory actually need to be manually updated?
Honestly, you should only touch it rarely. You really only update your semantic memory when the fundamental structural project rules change significantly.
Only update it when core project rules completely shift.
Yes, stability is the entire point of that specific memory layer.
So knowing the static rules is great. Semantic memory clearly has that covered. But rules are just that. They're entirely static concepts.
Right. Simply knowing a rule doesn't actually execute the physical work.
Exactly. How does an AI remember the actual complex steps required to get a job done? And how does it do that without bloating the chat?
For that specific challenge, we rely on procedural memory. If semantic memory is the what, procedural memory handles the actual how.
So procedural memory manages reusable workflows. It contains the operational step-by-step instructions for highly specific tasks.
In platforms like Claude Code, they represent this concept through dynamic tools. They call them skills.
And these are guided by a specific skill.md file. The source text gives a brilliant example of a newsletter review process.
It's a perfect real-world use case for procedural memory. It takes a highly subjective editorial task, and it standardizes it completely for the agent.
So you set up a distinct skill. You explicitly title it Newsletter Review. When that skill is triggered, it walks the AI through a very strict cognitive workflow.
Right. It seamlessly guides the AI through multiple distinct phases. First, it evaluates the title's hook.
Okay.
Then it systematically hunts for confusing grammar. Next, it cross-references the tone against the brand guidelines. Finally, it generates a polished draft with specific revision notes.
The true beauty of this system lies in its computing efficiency. These heavy, complex instructions sit completely dormant. They're entirely outside the active context window.
They just wait quietly out of sight. Until that specific task is explicitly requested by the user, it saves massive amounts of active computing power.
So you could have one highly detailed skill exclusively for investor slide decks.
Yeah. And you could have another entirely distinct skill dedicated to aggressively checking code, like before a major database merge.
Let me challenge this a bit, though.
Yeah.
When you describe it like that, is procedural memory just a fancy term for a basic macro? Or maybe just a saved prompt template?
If we connect this to the bigger picture, it's actually much more dynamic than a basic macro.
How so?
Well, a macro is rigid. It executes the exact same predetermined keystrokes every single time without thinking.
Right, so a macro just totally breaks if the user's input changes even slightly.
Exactly. But an agent uses procedural memory dynamically. When it retrieves that skill, it actively adapts those instructions. It tailors them to the nuanced context of the new draft.
So it's actively reasoning through the steps.
Yes,
Yeah.
it's not just blindly executing a brittle script.
That makes a lot of sense. It's an adaptable cognitive workflow, not just a fragile script. So how does an AI agent actually choose which skill to pull from its procedural memory in the first place?
The agent uses its baseline semantic rules to evaluate the current prompt. It identifies the core task type and then fetches the matching procedure autonomously.
It identifies the core task to fetch the correct skill.
Precisely. It independently evaluates the need, then retrieves the right tool.
Okay, so let's briefly recap where we are. We have the current immediate task isolated in working memory. We have our static rules securely anchored in semantic memory. And we have our complex operational processes defined in procedural memory.
It is a remarkably solid cognitive foundation for any functioning digital agent.
But what happens when the AI solves a totally new, highly unexpected problem? How does it actually gain real wisdom over time?
That brings us to the final and arguably most fascinating piece of the puzzle. We are talking about episodic memory.
Episodic memory is essentially preserving valuable, hard-won lessons from previous work. It's how the agent truly learns from experience.
But the critical distinction here is absolutely vital for builders to understand. This is not about indiscriminately saving full, bloated chat transcripts of every conversation.
Right, saving full transcripts is utterly useless. It just immediately recreates the exact context window overload problem we talked about earlier.
Full transcripts are terrible for memory architecture. True episodic memory is about systematically extracting and saving very concise, highly actionable notes for the future.
Let's look at the coding example from our source material. A developer is using Claude to debug a really stubborn authentication issue.
A very common, highly frustrating task. It can easily take hours of tedious trial and error.
They finally solve it together after a long session. Instead of forgetting that triumph, the AI saves a very short episodic memory to its database.
The memory might simply read, during the previous authentication fix, the actual error originated from the middleware layer. Always review that specific area first if a similar login failure appears again.
Quick pause. We should define that jargon for the listeners. A middleware layer is simply software connecting the operating system and applications managing data.
Perfect explanation. It sits right in the middle, routing information, and it's notoriously tricky to debug.
Whoa, beat. Imagine scaling to 1 billion queries. Beat. And the AI instantly remembers a specific middleware bug from 6 months ago without missing a beat. That is completely mind-blowing.
It is truly incredible when you see it functioning in real time. It completely avoids repeating the exact same expensive, time-consuming investigation from scratch.
The AI just skips right to the previously known solution.
Exactly. And this isn't just for software engineers. It works beautifully for writing, too. The AI can remember a specific user's preference to keep email introductions extremely short.
Simply by learning from corrections made on previous drafts.
But there is a significant catch to this entire system. You have to actively curate and constantly prune these episodic memories over time.
Right, because outdated memories eventually become massive liabilities. If your company updates its coding conventions, those old episodic memories must be aggressively removed.
If you don't aggressively remove them, they will actively sabotage your new work. The AI will confidently try to apply a deprecated old fix to a brand new system architecture.
And that causes complete chaos. So mechanics-wise, how does the AI actually know what piece of information is genuinely worth saving as an episodic memory in the first place?
Most advanced agents are prompted to check if a new insight successfully resolved a recurring failure. If it did, It synthesizes and saves it.
It saves concise lessons that solve major recurring task failures.
Exactly. It filters purely for long-term utility, safely discarding the conversational fluff. Sponsortetic.
Now that we've collected all 4 distinct Lego blocks of memory, how do we actually build functioning systems with them?
We have to look at how this plays out in the real world. Because how you stack these specific memory blocks is what makes a true agent fundamentally different from a simple chatbot.
A standard chatbot really just answers isolated questions in a vacuum. It relies entirely on the current conversation to summarize text or rewrite paragraphs.
Right. But a true agent autonomously accesses the right memory layers at the exact right time to manage complex ongoing projects over weeks or months.
The source material actually breaks down 3 distinct real-world tiers of memory setups. Let's walk through those architectures so you know exactly what to build for your needs.
Tier 1 is extremely lightweight. These are simple, highly focused, largely reactive tasks.
The example they use is a Zapier automation processing a fresh support ticket. It checks a basic condition. It uses a tool like GoodCall to automatically look up customer history, and then it logs the result in Zendesk.
For a rapid task like that, it really only needs working memory. It just needs the immediate current data to execute that single isolated transaction.
Forcing it to check deep semantic rules would just slow it down unnecessarily.
Exactly. Then we move up to Tier 2, which is decidedly midweight. These are usually persistent support roles interacting with humans.
Think of a dedicated customer support agent, like the Finbot from Intercom.
Vin absolutely needs working memory to handle the active, real-time chat with the frustrated customer. But it also explicitly needs semantic memory to reliably reference rigid company return policies.
And it desperately needs procedural memory, too. It has to perfectly follow highly structured step-by-step refund processes so it doesn't accidentally give away company money.
It has to strictly follow the static rules and the operational steps in tandem.
Exactly. But notably, it doesn't really need deep episodic memory. You don't want a support bot unpredictably applying a unique creative solution from a past edge case to a completely standard customer return.
Right. Then we hit the final level, Tier 3, heavyweight, long-term autonomous projects that require deep reasoning.
This is exactly where tools like Claude Code shine on a massive software project. A system like this effortlessly uses all 4 memory types simultaneously.
So it actively works on drafting a new API endpoint, which heavily occupies its working memory.
While simultaneously following the rigid architectural constraints perfectly outlined in its claude.md semantic memory file.
And then it autonomously runs a specific code checking skill, successfully pulled directly from its procedural memory, right before saving the file.
All while successfully recalling a very obscure past middleware bug from last month using its episodic memory. It is a beautifully orchestrated symphony of dynamic data retrieval.
This raises an important question, though. It truly is a complete, functioning cognitive architecture. But developers still make incredibly common design mistakes when setting these up.
They absolutely do. They inevitably overload the active context window, or they lazily save full chat transcripts instead of carefully curated, synthesized lessons.
They keep outdated memories lingering in the database indefinitely. You really have to start by explicitly defining the exact work your AI must complete, and meticulously work backward from there.
Precisely. You only add the specific memory layers that the core task actually requires. Don't build a complex Tier 3 brain for a simple Tier 1 task.
It's just overkill.
This actually raises a really important philosophical question for me. Human beings suffer terribly from outdated episodic memory, too. We constantly cling to old, familiar ways of doing things at work.
We really do. We stubbornly hold on to obsolete past procedures that simply no longer serve us in our current roles.
It is profoundly fascinating to me that we have to manually curate and explicitly program an AI's unlearning process. We actually have to explicitly teach these digital minds how to forget.
Because forgetting is a crucial, non-negotiable feature of a healthy, adaptable memory system. Without the innate ability to efficiently forget the obsolete, you are just left with paralyzing noise.
So, if you're building an agent and a complex workflow suddenly breaks down entirely, how do you actually diagnose which specific memory layer is failing?
You should always rigorously check the working memory first. Data overload in the active context is what typically starts causing those bizarre hallucinations.
Always look for active data overload in working memory first.
It is almost always the prime culprit when things wildly go off the rails.
So what does this all mean? Let's carefully synthesize this entire conversation into something you can take away and use.
The ultimate takeaway here is a deeply necessary shift in our perspective as creators and users.
The future of AI isn't just about endlessly throwing raw computing power at a problem. It's not merely about building massive models that aggressively consume entire data centers.
It is entirely about meticulously right-sizing the cognitive architecture. It's about how efficiently and intelligently you can organize the underlying information.
You have to perfectly give each agent the exact right context in its working memory. You give it the exact right foundational knowledge in its semantic memory.
You provide the exact right operational process in its procedural memory, and you curate the right foundational experience in its episodic memory.
And crucially, you deliver all of that at exactly the right time. That is precisely how we finally move from frustrating, forgetful chatbots to highly capable, persistent digital colleagues.
It is entirely about intentionally building a system that learns, adapts, and functions seamlessly alongside us.
2-sec silence. I want you to carefully think about your own biological memory stack for a moment before we go.
Oh, this is a really great conceptual exercise to ground all of this theory.
When you fail at a complex task at work, why did it actually happen? Was it a basic failure of your working memory? Were you just dealing with too many tabs open in your brain and got too distracted?
Or was it a semantic memory failure? Did you simply forget the fundamental underlying rules of the specific project you were assigned?
Maybe it was procedural memory. Did you carelessly lose track of your established workflow and skip a vital step? Or perhaps it was episodic memory. Did you just stubbornly fail to learn a crucial lesson from the exact same mistake you made last month?
Designing these advanced AI agents is ultimately a powerful mirror. It clearly shows us exactly how we structure and frequently mismanage our own human mind.
It really does. It's a remarkably powerful reflection. Thank you so much for joining us on this deep dive today. Keep building, keep learning, and please keep carefully checking your context window. We will see you next time. Out to your own music.